Okay, as we continue with section 8.8 on completing the square, this next type of problem, as you can see, the leading coefficient, not only is it negative, but it also is greater than 1. So we have to do something a little bit different first before we can complete the square. Now, normally you are taught to always factor out the negative, but also to factor out the GCF. In this case, my GCF would be -2. So I'm going to divide each term by -2. Yes, you can divide the 0 by -2, but you should know that already, that you are just going to get 0 on the other side of the equal sign. When I divide by -2, I get x squared minus 6x plus 10 equals 0. Now, because we are completing the square, the next step that I'm going to do is I'm going to bring this 10 over. So I have x squared minus 6x equals -10. Now, to complete the square, you are going to divide the -6 by 2 and square it. It's going to give me -3 squared, which gives me a +9. So I'm going to add 9 to both sides. When I add 9 to both sides, I get x squared minus 6x plus 9 on the left, and I get -1 on the right, sorry. Next, I'm going to factor. Maybe you can already see what's going to happen on this one, and it's great. You could shut it down at that point and write the final answer, or maybe it's going to take you to the step where you are going to take the square root to realize that you have a -1 over on that side. When you have a negative or any -1 or any number that's negative underneath the square root sign, you cannot take the square root. Therefore, your final answer is going to be no solution. Again, the problem was that there is a negative sign underneath there. Now, in this first problem, yes, I had to factor out a negative number. That didn't have any factor that was playing a role in getting a no solution answer. Not every single time that you have a leading coefficient that's negative is it going to definitely come out to be no solution. It just happened to be on that particular problem. Okay, so in this particular problem, it's set up for me to complete the square, so I'm just going to open it up a little bit. But as I stated in the last problem, my leading coefficient, I have to get rid of that. I cannot have any number besides 1 there. So my first step here, I'm going to divide by that number. It's not necessarily always going to be a GCF. As you can see, 3 is not going to go into -10. So I'm going to divide everybody by 3. It's going to give me x squared minus 10/3 x equals -1. Again, don't worry so much about this -1. It is not until you go to factor it that you will see that if it's still negative, then it's no solution. Okay, so this is the first one. It's on the uglier side here, where my middle term is not a nice number. I need to still divide this by 2 and square it. So in your head, or if you want to use your calculator, when you divide by with a fraction, that is the same thing as multiplying by the reciprocal. So the reciprocal would be 1/2, and then I'm going to square it. This gives me -10/6, which would give me, if you want to simplify this, so it's actually -5/3 that I'm squaring, it's going to give me 25/9. If you use your calculator, which is totally fine in that respect, even when you have to show me your work to get the 25/9, just make sure it is not a decimal that you're adding. So if you ask the calculator to do this math from the beginning, you got to be careful with your parentheses. And then when you get an answer, it's going to be a decimal. You have to ask the calculator using the math button and then fraction, and ask it to make it a fraction. You cannot have it as a decimal. So to complete the square, I'm going to add 25/9 on both sides. Okay, so let me rewrite this down below. Minus 10/3 x plus 25/9 equals, and I have to do that math of whatever -1 plus 25/9 is. That's the equivalent of -9/9 plus 25/9. That's going to give me 16/9. Okay, now I have to put this in factored form. Notice that that negative that was over there is now became a positive after I added the 25/9. This is definitely not a no solution problem. Now, putting this in factored form, so you got to rely on stuff that you might have remembered from last chapter. When this is in factored form, we got the x minus, but in order to know what number goes here, you can either the easier way would be to divide this, so you have 25, not divide, you're going to take the square root of 25/9. The square root of 25/9. The other thing you can do is whatever that middle term was, divided by 2. Those are the two ways to get what number is going to go here, and it is positive 5/3, so you have x minus 5/3. Now, you can take the square root. X minus 5/3 equals plus or minus. As you can see, what fraction was here is the 16 and the 9 are both perfect squares, so you have 4/3. So this one I can't leave. I actually have to do the math. If you want to split this up, one of them equals positive 4/3, the other one equals negative 4/3. I'm going to add 5/3. And this gives me x equals 9/3, which is 3. You may not leave your answer as 9/3. Over here, simplify this, it becomes 1/3. So my answer is 3 and positive 1/3. All right. One last one for this video is going to be this problem. Now notice there's a cursive B instead of an X. Again, that's not a big deal. Sometimes they will throw other variables in there. SATs and ACTs, they like to use symbols instead of a variable. You would still recognize that this is a quadratic trinomial regardless of what letter it is. The reasons for the X's would be simply if you were going to graph, but right now you're being forced to complete the square. So this one's also going to be a not so pretty answer. I have to get rid of the 3. So I'm going to divide everybody by 3. That's going to give me b squared minus 5/3 b minus 2/3 equals 0. Now, I need to open up that space to complete the square. So b squared minus 5/3 b equals positive 2/3. All right, that negative 5/3. This is where the fun is with the fraction. When you divide by 2, that's the same thing as multiplying by 1/2, and then I'm going to square it. So I have negative 5/6 squared gives me 25/36. That is what I'm going to add to both sides to complete the square. Okay. On the left, I have b squared minus 5/3 b plus 25/36. On the right-hand side, I need to find a common denominator, or if you're fancy, use your calculator. 3 goes in there into 36 12 times. 12 times 2 is 24. That is going to give me 49/36. Okay, I'm going to factor this. So I have b minus, just filling out the rest of the problem before I have to figure this out. Now you can do one of two things to get what term is going to go here. You can either take the square root of 25/36, which is 5/6, or you can take the 5/3 and divide it by 2, still giving me 5/6. As you can see, that number was already right here. When I was trying to find out how to complete the term, that number is always going to already be used somewhere in the problem, so it's going to feel a bit familiar. Next, we are going to take the square root. When I take the square root on the left, I get b minus 5/6 equals plus or minus 7/6. Square root of 49 is 7. The square root of 36 is 6. Now, split these into 2. one equaling positive 7/6, the other equaling, equaling negative 7/6. I'm going to add 5/6. That gives me 12/6, which is 2. I'm going to add 5/6 over here. This gives me negative 2/6, which I cannot leave my answer like that. I would write negative 1/3 instead of negative 2/6. Now, if that wasn't enough fun for you, now we're going to have some fun with the word problem. They do not give me an equation here. This is the first one that they didn't give me an equation. It says a landscaper is designing a rectangular brick patio. She has enough bricks to cover 144 feet squared. She wants the length of the patio to be 10 feet greater than the width. What dimension should she use for the patio? Well, first of all, finding the area of anything that is a rectangle, you would use the formula area equals length times width. So I have the area, which is 144. Now it says she wants the length of the patio to be 10 feet greater than the width. So if I call the width W, she wants the length to be 10 feet greater than. Greater than would indicate that you are adding. So I have W plus 10. So I have 144 equals, when I multiply this out, I have W squared plus 10W. Just because every single problem that we've done so far, the number has been on the right, I'm just going to flip this around. Again, if you want to leave it like that, that's fine. I'm also going to rewrite this just to open it up so I'm able to complete the square. So to complete the square, you take your middle term, divide by 2, and we're going to square it. That's going to give me 25. This next one, you have 2W squared plus 10W plus 25 equals 169. I'm going to factor this. Next step is going to be to take the square root. W plus 5 equals plus or minus 13. Now, when I split this up into positive 13 and into negative 13, the negative 1 is going to become a problem. 13 minus 5 is 8. Negative 13 minus 5 gives me negative 18. Now, under normal circumstances, my answer would be 8 and negative 15. However, you can't have the side of a rectangular patio be anything negative. So my answer is 8. That would be my width, would be 8. I think they were talking about feet. Were they feet? Yes. It says what dimension should she use for the patio? So if my width was 8 and then my length had to be 10 more, I would add 10 to 8 and I would get 18 feet. Now, if this wasn't so pretty, when I say pretty, I mean the fact that the square root of 169 was not a perfect square, you would start to have decimal answers, because those square root ones that we had earlier in the lesson or in the previous video, we had something like, 4 plus or minus the square root of 21. In a word problem, they will ask you to round, because if it doesn't come out to be something perfect, like this one was 8 feet and 18 feet, you would have to make it a decimal. That's the only time you're going to convert those square root answers into a decimal, would be when they ask you, and they always ask you in word problems. It's kind of like a hint that it's going to be a decimal answer.